Number 15 says n is our incenter. Find the value of x. If we have an incenter, that means we have angle bisector at B, we have a bisector at C, and at angle A. So what we're going to do for this point is just start labeling what we know. When we have an incenter, that means we have the distance between KN, NL, and MN are congruent. Because when we have an angle bisector, angle bisector, angle bisector, angle bisector, angle bisector, angle bisected, and then we have an angle bisected. So we have the properties right here. One of the big issues that we have with this problem right away is that we see we have MN as our 4x, but we know we can't really solve for it yet. So what we have is a bunch of right triangles. When we have a right triangle, when we have two of the given points right here, we know we have to use the Pythagorean theorem. Right here, we have a right triangle or right angle, and it's opposite of 52. That means that's our hypotenuse. So to solve for NL, we need to figure out what is the missing side, NL. So we need to set it up. So NL squared plus 48 squared equals 52 squared. And from here, it's just basic arithmetic. So 48 times 48 gets you 2304 plus NL squared equals 52 squared gets you 2704. So from here, we're going to combine like terms. Subtract 2304, subtract 2304. So we subtracted 2304, you get 400 is equal to NL squared. If you see right here, we do have a square, so we do have to do the inverse of what a square is, which will be a square root. We get 20 is equal to NL. Well, the distance between the incenter to a side is equivalent between all of these Kn and L and Nm. So what we need to do here is we have 20 is equal to 4x. And to solve for this problem, we just have to do an inverse operation of multiplication. So we divide, get x equals 5. So, based off our knowledge of angle bisectors and the property of an incenter, we end up getting 5x, or 5 equals x.